Good afternoon.
Good afternoon, sir.
Let's wait for 1 or 2 minutes more.
Yes, sir.
അമ്മ ഇതെന്തിനാ? ഏ? Okay.
Okay, so let us start this fifth module. Okay, is it visible to you, the slide?
Yes, sir.
Okay, so this module, that is fifth module, is also there in your IA2. So if you see the syllabus, then your fifth module, belts, chains and brakes. Okay, so this module will also be there. Then cam and follower. Okay, and the second module, that is special mechanisms. So module number 2, 4 and 5 will be there in your IA2. So let us quickly start the fifth module, that is belts. It is belts, chains and brakes. So looking at the topic name, you can easily guess that what should be the content of this module. Belts and chains are used to transmit power from one shaft to another shaft. Means belts and chains are the power transmitting elements, mechanical elements. While on the other hand, there is some part of the brakes in your syllabus. Okay. Next, let's see what is belts. Okay. So as I told you that belts are used to transmit power from one shaft to another shaft by means of pulleys. Okay, so what you have to do, suppose there are two shafts, shaft A and shaft B, and suppose power is generated at shaft A, but your application, your load is at shaft B. So now you have to transmit this power from the source point to the requirement point. Okay, so belts offer you one of the means to transmit the power from one shaft to another shaft. Okay, and generally belts are used when power transmission has to be there over a longer distance. That is, the distance between two shafts is quite large. In that case, you do not prefer the gears. Okay, you go for the belts. Okay, so that is one important point about the belts. So, what are other power transmitting elements apart from belts? There are chains which you find in your automobiles, two wheelers. Okay, then gears are there which are used to transmit power between two shafts when the distance between two shafts is less, and when you do not desire a sleep, if you do not desire the presence of sleep while transmitting the power, then you can go for the gear drives. Okay, because gear gears mesh with each other with the help of teeth present over them. Okay, and by meshing of these teeth, there is no chance of slipping of the one gear over the another one. As in case of belts, it may happen that this belt can slip over the pulley. Okay, that's why, because of presence of slip, these are known as your negative drives. And if slip is not present, then the drive is known as positive drive. Okay, so how they transmit the power, how the belt transmits the power, what is the mechanism by which it transmits the power? That is nothing but the mechanism of friction. Okay, you know that there is sufficient amount of friction present between this pulley and belt. Okay, so because of this friction between these two, what happens that when the pulley rotates on driving side, then it also carries the belt with it, because of there is connection between pulley and belt because of the friction present them. Okay, and when the same belt passes over the driven pulley, then what happens that this belt carries this pulley forward with it because of friction, because there is friction between pulley and belt. If suppose by any reason friction is not sufficient between pulley and belt, then what will happen? Slip will happen. That this belt will only uh, move and it will not rotate the pulley with it at some point. Okay, so because of that, what will happen? Loss of speed will happen. That belt will be at some other speed, but speed of the driven pulley, it will be less than the belt speed. And on the driving side, what will happen? That speed of the driver pulley will be more, and speed of the belt will be less because of slipping. Okay, because of reduced friction. So these are some disadvantages which are associated with belts. Okay, so are you getting this?
Yes, sir.
Okay. Also, please put down your attendance in chat box in first session only. So now let us. Then what is the concept of this slack side and tight side? I will also explain that. Okay. Then uh, how will you select a belt drive? Different factors which affect the selection of a belt drive are, you can see, speed of the driving and driven shafts at what are their speeds. Then speed reduction ratio. Okay, what is it? Suppose suppose N2 is nothing but your speed of the driven pulley. Okay, output shaft. Speed means RPM. Okay, revolutions per minute. And say N1, N1 is the RPM of your driving pulley. So this ratio is called as velocity ratio. Okay, so how much you want speed to reduce when you transmit the power? For example, here you can see that on driving shaft, larger pulley is fitted. Okay, so not always the case. It might happen that driving shaft may carry a smaller pulley, may happen, and the driven shaft may carry a, you know, larger pulley. So it depends on application. So you can see on driving shaft a larger pulley is there, and on driven shaft a smaller pulley is there. So driving pulley will complete one revolution, and at the same time the driven pulley will complete more than one revolution. Its speed will be depending on the diameter of the pulley. Okay, so how much you expect, how much is your requirement of velocity reduction? Based on that, you can select a particular belt drive. Then power to be transmitted, whether you want to transmit a moderate amount of power or huge amount of power you want to transmit. Then center distance between the shafts. So there is some range that if the shafts are in this range, the distance between them is in this range, then particular drive is suitable for that. Okay, center distance between the shafts, how you will define? That is nothing but your this distance. This is called as center distance. That is center to center distance of two shafts. Okay, then positive drive requirement, whether you want, whether you are okay with presence of slip between belt and pulley, or your application is very precise, you cannot afford the presence of slip, it will affect the functional requirement of your drive. Okay, so accordingly you can select whether you need a positive drive or a negative drive is also okay. Then shafts layout, whether your shafts are like parallel or like how they are arranged. So it is the axis of the shaft, whether they are arranged in this fashion, in this fashion, or in any other fashion. Then space available. So depending again it will affect. Some belt drives or some drives are very compact. In order to have the particular speed reduction ratio, okay, you will need that much space for it. Okay, so some drives offer the solution in very compact manner. So depending upon space available for your application, you will select a particular belt drive. Then service conditions, that the conditions, environmental conditions or the conditions of the surroundings under which the shaft is supposed to work. So based on these conditions, also you will select a particular type of belt drive. Okay, so all these factors affect the selection of belt drive. Then types of belt drives. What are different types of belt drives? So they are classified based on different criterias. Okay, so one such classification is depending on the belt speeds. Belt speed, you can say, or based on the amount of power to be transmitted. Okay, so there are light drives. In light drives, the belt speeds go up to 10 meter per second. Okay, applications you will find in agricultural machines, machine tools which you use in workshop. Okay, then medium drives. For medium drives, the belt speed range is from 10 to 22 meter per second. These drives find their applications in machine tools. Then come to the heavy drives. So heavy drives are used to transmit heavy or huge amount of power. Belt speeds are about 22 meter per second, and these drives you can find in generators and in compressors. So in order to connect the shaft of compressor to the electric motor, okay, you can use this kind of drive. Okay, so based on belt speeds, the drives are classified as light, medium drive, heavy drive. Okay, the next topic is your types of belt. Okay, so this classification, see, this is type of belt drive. Okay, and this is types of belt. So based on the cross section of the belt, the belts are classified as flat belt, V belt, and circular belt or rope. So you can see in flat belt, the cross section of the belt is rectangular. Okay. Then in V belt, the cross section of the belt is trapezoidal. It is trapezoidal. It is like this. So in order to accommodate such kind of belt, V-shaped groove is there in the pulley. Okay, where the belt runs over the surface of the pulley. So it looks like this V belt. So V belt cross section is trapezoidal. Okay, here it is not that clear. Then in circular belt, again circular belt needs some sort of grooves in order to be on the uh, on the pulley. So circular belt is of circular cross section. You can also call this as rope drive, rope. Okay. So even with the help of ropes, it is possible to transmit the power between two shafts using pulleys. Okay. So advantage of V belt is that because of this wedging action, because of this wedging action, there is more friction between belt and pulley. Okay, hence power transmitting capacity of V belt is more than that of the flat belt because it offers more friction. V belt offers more friction between belt and pulley. If friction gets reduced, automatically your power will not be transmitted. Power will be available at your driving pulley, though it is rotating very fast. Okay, but because of the slip present between belt and pulley, your driven shaft will not get complete motion of this. Slip will slip will occur at two places, at driving pulley between belt and driving pulley, and second between belt and driven pulley. Okay, so there will be double loss of the power. So there must be sufficient amount of friction between belt and pulley surface. So here you see the flat belts are used in applications of moderate power transmission. Moderate amount of power transmission के लिए आप flat belt use करते हो. And the distance between two shafts, this distance between two shafts should not be above 8 meter per second. Sorry, 8 meter only, not meter per second. It's wrong. 8 meter. Okay. So obviously when the distance between two shafts is large, then only you use the belt drive. If suppose two shafts are present very close to each other, then you can go for gears. With the help of gears, you can transmit the power, or you can use the coupling, some sort of coupling. So we have seen one type of coupling, Oldham's coupling, then universal coupling, Hooke's joint. Okay, so such is the case. V belt, okay, its power transmission is moderate range. Oh, okay, and when pulleys are very near to each other, okay, even you have seen the V belt in your that sugar cane juice machine. There you can see its application. You will find it at many places. Flat belt you will find in flour mills if you want to see. Okay. Then in flat belts are also used in power plants as a conveyor. Okay. Then circular belt or rope. These are used in heavy power transmission. Okay. When distance between pulleys is above 8 meter per second. So circular belt are also as efficient as V belt in power transmission because of again this wedge action. Because of this groove, this rope firmly sits in the groove surfaces. Okay. Then when very huge power is to be transmitted, then what you do? You use wide pulleys with number of grooves. So here in this pulley only one groove is there. Okay. So when if you want to transmit very huge amount of power, you will need sufficient amount of friction over there. In order to increase the friction, what we do, we go for very wide pulleys which have the multiple grooves in this like this. So you can easily uh, have three V belts or three rope here. like this. All will be here and they will be transmitting the power between the two shafts. So it is about the types of belt and uh, their corresponding applications. Then which materials are used for belts? So you know that material of the belt should be mechanically strong, should also be flexible. Okay, because we have seen that one side one side of the belt is in more tension. Here in this side there is more tension in the belt. That's why it is called as tight side. And the other side of the belt is having comparatively less tension, which is called as slack side. Okay, so as it is in more tension on one side, less tension in other side, so your material of the belt should be flexible, that if force is acting it should get elongated, if less force is acting it should get back, it should get contracted back to its original length. That's why it should also be flexible and it should have durability, that you can use a belt over a long time. Okay, with high coefficient of friction of the belt material should be high. So generally materials used are your find leather belts, cotton or fabric belts, then rubber belts and balata belts. So balata is also a material like rubber, but it has superior qualities than rubber. Okay, so these are the few materials I listed out for your reference. Then types of flat belt drive. Okay, again we have seen the types of belt: flat belt, V belt, and circular belt. Now we are seeing the types of flat belt drive. So belt used in these drives is flat one, the one with rectangular cross section. So you see the first one, open belt drive. So how belt is wrapped over the pulley, you can see in this case. Okay. So as what happens, so power is available at the shaft A, which is known as driving shaft, over which this pulley is mounted. Okay. If you see the pulley will look like this. You are already aware. Okay. So over its surface, there is belt running like this. So what happens at driving side where power is available, and driven side is where power is transmitted. So here application is present, like some motor is there, pump is there, compressor is there. Application will be connected here at the driven end, and here power source will be available like generator, turbine, electric motor, etc. Okay. So at driving side, what happens when this pulley rotates like this? When it pulley rotates like this, what it does? It drags the belt at this side. It will pull the belt like this with it. So because of this pulling of the pulley, this side becomes tight side. Some tension is there in this side. Okay, and when the same pulley uh, carries the belt forward here, and here it has to uh, give away the contact, between belt and pulley. So at this point, what happens? The push the pulley pushes the belt here like this. So because the belt is getting pushed, not pulled, so this side becomes slack side, means the tension in this side is less as compared to the tight side tension. Okay, so that's why this tight side and slack sides come into picture. You can see that in slack side the belt becomes loose. Okay, it does not, it appears like this. It does not remain straight because here force is less in the belt. So somewhat because of its weight, it sags here. Okay, so in open belt drive, what happens that the two pulleys, driver and driven, both rotate in the same direction. It is rotating like this. The belt is moving in the direction of driving pulley. Then the same belt moves the driven pulley here in same direction. That is clockwise, clockwise. Okay. They, but in case of crossed or twist belt drive, pulleys rotate in opposite direction. So you can see how it is arranged. You have to literally twist the belt, okay, so that you can have the directions of two pulleys opposite. So one is rotating clockwise, one is rotating anti-clockwise. Okay. So but what happens in this case, that many times these two belts at the cross point, they rub with each other, and because of that wear of the belt takes place. Okay, so in order to avoid it, you need to have the considerable width of the belt. Okay, so that this distance between them can be increased. So this is one open and this is the crossed belt drive. Then see again how quarter turn belt drive. So how the uh, layout of the shaft is here. One shaft is vertical. Okay, it is in the plane of this paper, and another one is just horizontal. It is coming to it is the perpendicular to this plane of paper, and you need to transmit the power. So in this way you can transmit the power. Okay, then quarter turn belt drive with guide pulley. So with the help of guide pulley you can give a proper direction to the belt. Okay, so that you can transmit the power in desired layout of the shaft. So here both the shafts are in the same plane. You can see that is the plane of paper, plane of your screen here. Both are in same plane, but here the this shaft is in the plane of screen and this one is perpendicular to the plane of screen. So with the help of guide pulley, you can properly guide the belt in order to transmit the power for the given layout. Okay, next is your belt drive with idler pulleys. Okay, so you can see that in addition to driving and driven pulleys, idler pulleys are also used. So what are the functions of these idler pulleys? Okay, so one can see that it is supporting the belt. If the distances between the two pulleys are more, okay, it might happen that after some time the belt will start sagging. Okay, so initially it will run in tight condition, but over the time it might become sag like this. So uh, in order to control the force between pulley and belt, this idler pulley can be used. You can adjust the distance of it. Okay, suppose if you find that again the belt has loosened, then you have to again shift this pulley somewhere upward. In this way you will increase the angle of contact. So this is called as angle of contact, over which the belt makes contact with the pulley, is called as angle of contact. So this angle you can control with the help of idler pulley. It also supports the belt. Okay. Second, in order to give the direction, order to give the direction to the belt, in order to have the multiple driven pulleys, only one pulley is here, which is the driver, and now power is to be transmitted to three different driven pulleys. Okay, so in order to control the direction of belt, these idler pulleys are used. If you will directly connect it like this, the belt is तरह, so what will happen, that the power will not be transmitted efficiently to all, because what will happen, the angle between the belt and pulley surface will change, and it depends on this angle, that how much power you are transmitting, which is called as angle of contact. More it is, more a belt is capable of transmitting the power. So it is uh, one of the thing, belt drive with idler pulleys. Then next is compound belt drive. Okay, so in case of compound belt drive, you can see when you have to use the you have to transmit the power over a longer distance. Okay, for example, shaft 1 shaft 1 you have to transmit the power to shaft 2. Okay, but distance between them is quite large. So what you can do, you can use the intermediate pulleys, and with the help of that you can transmit the power from shaft 1 to shaft 4. So such kind of belt drive is called as compound belt drive. Okay, again compound belt drive is helpful to reduce the speed considerably. So we have defined the velocity ratio, speed reduction ratio, as that speed of the main driven pulley. So main driven pulley is here 4, and speed of the main driving pulley. So it is the that. So you can see that your driving pulley is larger. Driving pulley is larger here, and here it is the driven pulley. Okay, so obviously the speed of the driven pulley N2 will be greater than N1. Okay, so one minute is remaining. Let's continue after joining back. You can note it down, you can see it. Okay.